So what is this? So this is a 20-ish long video series. Very short, these are going to be 5 minutes to 10 minutes each. That will guide you through the basics of Java. So we're going to be looking at, firstly, how to download Eclipse and the Java Development Kit. Then to write your very first program in Java, just a simple hello world. And then we'll do things like look at data types, control flow statements, loops, switches, arrays, methods, and all that sort of stuff. So hopefully by the end of this, you should be able to do pretty well on your Java test, which is in May. So what should we do first then? Let's begin by downloading Eclipse and the Java Development Kit so you can begin working on things at home. So first step is just to simply open Google or any kind of search engine and type in Java Development Kit. And there it is. So you'll find this link here to Oracle. If you click on that, all the different versions of the Java Development Kit are here. So the SE Development Kit 8U77 is what we want. You'll have to click Accept License Agreement there, and then find which one is yours. Now I'm working on Mac, so I'm going to download this in just a second, but I know a lot of you have Windows machines, so any one of these two, depending on whether you've got a 32-bit or 64-bit machine, is here. So just click on those. So I'm going to click on that, and it should start downloading. Fab. While that's going, I'm going to start a new tab, and I'm going to search Eclipse. Download. Hey, number one. There we go. So we want that. Now, again, I'm on Mac, so this should pick up my system here. It says Mac OS X Cocoa. But if you're on Windows again, just click and go to Windows. And all of these options just here should begin to change. So you can see that now Windows. I'll go back to Mac for now. Now the one we want is Eclipse IDE for Java developers, and that's this. I'm going to click directly on the 64-bit, and that should take us to a download page here. Any one of these is fine. I tend to go for the IBM one because it's quickest. Click on that, takes you to a new page, and then it'll say Mac Cocoa. It might say Mac for Windows, not Mac for Windows, it might say Windows or whatever it is there, but you'll get the idea. So I'm going to click on that, and that's going to start going too. Okay, these little monkeys should have downloaded by now. So I'm going to minimize that, and the files there will have appeared on my desktop. They may appear in your downloads folder. Who knows? It depends where you've got your download set to. Order to do these then. So best off first opening the Java Development Kit. So on Mac it's simple to install really. It's just a case of just double clicking there and following procedure. Writing files, here we go. That's Mac. So that's done. And then once you do that, you just unpack Eclipse. Now this will be slightly different for Windows, but on Mac it should just reveal an application there, which you can go and use straight away. I've got a version of that down here, so I'm just going to throw that in the trash. But at this point, you should be able to simply click Eclipse, and it should open like that. You should get a screen like that, and that's where we're going to leave things for now. Thanks very much. We left last time with Eclipse open, which is a good start, and now we kind of want to work our way around the IDE a little bit. First question is, what is a workspace? Well, a workspace is simply a place where your Java projects will be stored. So it's kind of good practice to set yourself up a nice folder somewhere in your file system that allows you to obviously find your work, but also to make sure that you don't have to keep moving it around. We don't want to keep moving our files around because it becomes a bit of a pain. But for now, I'm going to stick mine on desktop. Set yourself up in your folder, of course, but for now, desktop it is for me. I'm going to click OK. And she starts to open. There we go. and you'll be confronted with something that looks hideous like this. Now you all should be fairly familiar with this interface, but even so, I'm just going to run through certain aspects of it. So this is something called the Java Perspective. So this should technically have all the windows we need to start developing good Java programs. So on the left we have something called the Package Explorer. So this is where we're going to see all of our projects, our Java projects. These will be split into packages and classes, but we'll look at that in just a moment. You'll have this big window here, and this is usually where we do most of our coding. So as soon as we start a project, you'll see in here we can start to type stuff in. At the bottom, you should see the console. So if you're going to print something out from a Java program, it's going to appear down here. If you don't see any of these things, a couple of things you can do. You can go to Window. This should be the same on Windows too. Go to Perspective, Open Perspective, and there'll be a Java one on there. Mine's up here for some reason. Or you can go to Show View. Say if you don't have the console, you can click on Console and it'll be added to this taskbar at the bottom here. So we're going to start by making a very simple project. So I'm going to go for File, New, and then Java Project. Okay, so this is going to allow us to give the Java project a name. So in convention, Java convention, we capitalize the first letter of any project name. So let's go for Hello World. So hello and then capital W, LD like that. So capital H and then capital W. This idea of capitalizing every other word is called camel case. So hello world, my name is Lee, would be like that. Just capitalize the first letter of every word. We don't need to worry about any of this stuff down here. For now, just hello world. So I'm going to finish that, and it opens up a package. Now you should have noticed that it appears on your workspace. So in here we have all the various files that we need to run a Java project. At the moment they're empty because we haven't really done anything with them, but we have a folder with the hello world name, which is what we want. So now we need to create a class. So I'm going to select the package, click File, New, and then down to Class. I usually keep the same name, again using the same conventions of capitalizing the first word and every other word past that. So hello world. Some people forget to click this, but we're going to need to click this. For now, let's not worry about what that is, but just know that we need this. I'm going to hit Finish, and that should open a file structure here and open our first Java project. There it is. So I'm going to delete that for now. We don't want that. But what I'm going to do is show you how to comment. So it's really good practice at the beginning of any project is just to label it up a little bit so we know what it actually does. So we can do that by just typing in. So this is my first Java project. Yay. It prints hello world to the console. Now that's just destroyed my screen with errors, basically, because we haven't commented out. So I'm going to just tap / twice in front of every comment. As you see now, it goes green. When it's green, it's a comment, and the essentially this text won't be compiled by Java, by Eclipse. So we should be all good now. What I'm going to do next is just put a simple statement in. I'm going to put a system.out.print parenthesis, and in here I'm just going to put hello world. There we go. So system.out.print open parenthesis hello world in speech marks, close parenthesis, and semicolon. So that's our first instruction there. So this should, in theory, print to the console, which is down here, the words hello space world. To do that, we need to press that green button there, which is kind of like a run button. Hit that. It thought about it for a little while, but there it is. So hello world. We can keep doing it. Put my name is Lee. I'm going to run that again. And we've encountered a small problem here where that first word has bled into the next sentence. So simply what we're going to do there is change print to println, which is going to print those words on a new line. There you go. So you can experiment with the ln. If you move that there, you notice that it doesn't add a carriage return. Add it back and it adds a carriage return. So simply the println is going to print out what's in the parenthesis and then a carriage return. So actually I don't need an ln there and it should still work fine. Great. That's a Hello World program. See you soon. Welcome back. If you can hear a tumble dryer in the background, that is because I am highly domesticated. Okay. So what's this about then? Today we are going to try and import a project into Eclipse, so a pre-existing project. So if you've ever been on Minerva, which I'm sure all of you have, you'll notice several kind of little mini projects that are on there, which you can download, import into Eclipse, run, mess about with, and figure out what's going on. So when you do that, you download Minerva and you'll have a folder like this somewhere. I've put mine on your desktop, but for you, it's going to be in your individual workspaces. So the idea here is to get that into Eclipse, to run it and for it to work. So this is how we do it. Again, this is going to be pretty much the same for Windows as the options here are fairly similar between the two platforms. So here we go. File. I'm going to go to Import. And then you actually get this. Pretty hideous, to be honest. You want to expand the general folder, and then there's an option here for existing projects into workspace. Click on next, and then you need to go and find your work. Desktop. I'm going to click on secret project. That's the one we want to import in. Press open, and all looks quite well. I'm now going to hit finish. And there it is, it's in there. And now this is just the package. You're going to have to expand this to find the class. So expand the package, expand src, expand default package, and just hidden in there is the project, secret project. Double click on that, and there you go, it opens up. So we've got a standard project, been naughty, I haven't commented it, but there you go. And then a printout statement. So I'm going to print that, and there he is. Jeremy Corbyn is printed to the console. And then you can, of course, do whatever you want with that. George Osborne. Yeah, little verses. And you can work on it as normal. Quick and easy one, but some people get stumped by that. Thanks so much. Welcome back, lovers and haters of Java. So what we're going to do today, we are going to look at data types today. So we're going to be thinking about different types of data. So ints, strings, chars, boolean, doubles, that sort of thing. And what we can do with them, what they are, how to get them to print out in the console, etc. So standard procedure, we're going to go to File, hit Java Project. I'm going to call mine data types, making sure to conform to camel case convention. Going to hit finish, select standard, class, and then data types again. Clicking on that. First thing I'm going to do is comment in here. So this is a Java program about data types. Now I'm going to start adding in some authors and versions as well. So I'm going to add author. Scott. And at version v1. It's good practice to try and have a version number on there. It just shows other people how many iterations of this particular program there are. So this is number 1. That always appears. I'm going to delete that. And we are ready to code. So the first data type we're going to look at is probably the one that you're going to encounter the most, which is an integer. So an integer is a whole number. So an integer could be 4, it could be 45, it could be 841, it could be 19,523, it could be anything. Anything that's not got a decimal point. We have data types for decimal points, but for now, these must be whole numbers. So how do we write one of these? Okay, well, int is how we declare the data type. So int is short for integer, of course. Now what we're doing here is creating a variable. Now a variable is simply a box in which holds a value. So I want to create a box that contains an integer and then put an integer value within the box. So I'm going to start by making the box. So we know it wants to be an integer, and I'm going to call the box my integer. And then again, we've got camel case, so that's every other word is capitalized. Now for now, I'm going to put a little semicolon there. Now what we've done there is basically declared an integer called my integer. Okay. Step 1, complete. So next what we're going to do is we're going to take our box, we're going to open it up, and we're going to throw in a value. So we need to select what box. I mean, there might be many boxes, so I'm going to just define the box I want, so my integer. And then I'm going to put equals, and let's go for 7. So there we go. Now this stage is called initialization. So we've initialized the variable my integer with the value of 7. Okay, now the reason we've got a little warning triangle here is because we haven't actually done anything with this variable. At the moment it's just sitting there, it's not being used. So I'm going to use it by printing it out. So I'm going to go for system.out.print. In parenthesis, I'm going to, instead of putting something like hello world this time, which will print hello world, I'm going to ditch these speech marks and just put the variable name, so my integer like that. So what will happen here is this print statement will look for the variable my integer, it'll find it here, it'll realize it's an integer, it'll then notice that it's initialized with the value of 7, and it'll print out 7 down here. So let's try it. Run, and there's the 7. Fantastic. Now, there is another stage to variables. The reason we have a variable is because we can change it. We want to change it. When you vary something, you change it. So it might begin as 7, but later on in your program, it might, say, become 12 or 16, whatever it is. Now, this stage is not called declaration, it's not called initialization, it's called assignment. So if you've already given the variable a value, that's initializing. If you're changing the value, that's assignment. So I'm going to type in my integer to select the correct metaphorical box, and then put equal to, say, 12. There we go. So this is your assignment stage. There we go. So if I print that out again now, system.out.print my integer, you will notice what happens. Let's put the ln's in so we get them on separate lines. Run them. So you have 7, which is the initial value of my integer at that point. And then when it's assigned with the value of 12, the variable my integer changes to 12 and it'll get printed out there. So you can see that can just continually happen throughout your program. It's useful for a whole bunch of things, but they're essentially the core of most of your programs, is these changing variables. Right, so that's an integer then. We could go and add some integers together. So if I create another integer, I'm going to call it int another integer. And this time, instead of declaring it on one line of code and initializing it in a second line of code, I'm going to put it all in one line. So I'm going to declare there and then initialize directly afterwards. So you're going to put int another integer equals, and I'm going to go for 18. So that is declaring and initializing on the same line. It's kind of like shorthand, sort of. Right, I'm going to get rid of that just for now, so we don't get confused. But essentially we've got two integers now, one called myInteger, which is set to a value of 7, and one called another integer, which is initialized to a value of 18. So I'm going to try and add them together. So we can go to system.out.print ln, and then I'm going to add them together. So myInteger plus, so I have the plus operator, and then another integer. Now Java's clever, Eclipse is clever. What it'll do is it'll look at the value of that, which we know is 7. It'll look at the value of that, which we know is 18. It'll add them together and give us a result on screen. And there it is. Now there might be a point where you don't want them to be added together, you just want them to be placed side by side. You can do that by adding a couple of speech marks there with a space in between. Now this is essentially a string, which is something we're going to look at in a moment, but you'll see what happens now. So we'll do that. You'll have a 7, you'll have a printed space, and then you'll have an 18, which is, of course, another integer, the value. Great, so that's the integer. Let's look at doubles. Now doubles are simply decimals. So they're not whole numbers like 3 or 4. They are decimals. It could be 7.5, could be 8.543, 87.543, whatever we want, really. But they're set up in very much the same way. So you declare them using the correct data type and initialize them. So I'm going to use the shorthand method here to do this. So I'm going to type in double and then give it an appropriate name. So my double, and then set it to a value of 6.3, semicolon. So that semicolon always goes again on the end of our instructions to show that it's the end of that particular statement. Just to check it works, let's try and print it out. Okay, so it's looking for the variable myDouble, looks up here, realizes that it's a double, and realizes that it's initialized with the value 6.3. Going to run it, and there it is. So that's our double. Let's move on to Boolean. So Boolean is something you'll have encountered within your logic gate work before. Now a Boolean can only have two possible outputs, only outcomes. Whereas, an integer could have, well, it's got an infinite number, hasn't it? And so has pretty much doubles. But Boolean has only true or false. That's it, just the two. So to set up a Boolean, type Boolean, give it a name, my bool, where we usually abbreviate Boolean to bool in code, and we're going to set it to the value of true. There we go. Same old story. Let's try and print it out. In the parenthesis, we'll put my bool, and it should give us true. Fabulous. So we've done integers, the whole numbers. We've done doubles, which are decimals, and we've done Boolean, which can either be true or false. Now, Boolean will be something that we'll be looking at in detail when we're checking out if statements and loop. That's just what it is. Let's look at some character-based stuff now. So we want to be able to print out letters and we want to be able to print out words. So let's start with letter. Now a letter is a character. And what's short for a character? Char. So let's go for char, my char. I'm going to set it to, and I want to print out just a single T. So I can't just put T like that. Because if I just put T like that, then it's going to think that T is a variable somewhere. It's going to think there's a box called T. So we need to give it some symbols to show that it is a char. And that symbol is this apostrophe here. Okay, so we're going to have apostrophe, T, and then apostrophe. Print that out. My char, and it'll appear in the console. Now it won't appear with the apostrophes, of course, it'll just be a T on there. Now what we've looked at so far, these are all called primitive data types. So primitive data types can't be broken down into anything smaller. So a whole number is a whole number. How can you break down a whole number anymore? You can't really. But there are non-primitive data types which are a bit more complex. These are essentially things that are made up of smaller things. One we're going to look at today is called a string. Now a string is essentially a series of characters put together. So that could be a word, it could be a sentence, it could be a paragraph. But basically, they are made up of lots of chars and lots of different symbols. So I'm going to try to make some. I'm going to put string, my string, and I'm going to put equals and set it to hello world. Semicolon at the end. Now, subtly and a bit annoyingly, I'll be honest, within Eclipse, I think Java more widely, is that string is capitalized, whereas char, boolean, double, int, whatever else isn't. So it's just, you just got to be aware of that. So when you're writing a string, when you're initializing it, you must make sure that you're using speech marks here. So if you think of words and sentences and then speech, you can see how the two align. Let's print it out. System.out.println, and then in our parenthesis, put my string. And lo behold, there we go. There is our string there. So just to recap, we've covered variables, the different stages of creating a variable. So declaring essentially a box with a particular data type. So this one is a whole number called my integer. And then initializing it, or basically putting in a value of 7 there. So those are integers. We looked at doubles, which are decimal numbers. We've looked at Boolean, which resolves either true or false. More on that later. We have looked at chars, which are simple characters. I mean, you can put anything in there like that. It doesn't have to be a letter. It could be any old character. And we've looked at strings, which are non-primitive data types, which are made up of lots of chars and are words or sentences or paragraphs or whole books, whatever it is. And that's data types for now. Bye. So this video is about unlocking the mystery of concatenation. So it's quite a complex word, but it actually has a very simple meaning, and that is to link things together in a chain or series. So what's it got to do with Java? Well, we might want to print out a variable, say 6, but at the beginning of that variable we want to tag on the words my variable is, colon, and then the variable itself 6, to give a nice sort of succinct sentence which tells you what that variable is. So I'm going to look at how to do that. Let's just get rid of Google and start a new program. So this is going to be the last time that I start it from scratch like this. You should be pretty good with starting with creating packages and classes by now. So concat n8. Definitely not going to try and spell that twice. So let's do that and go for class. Put that in, click that. There we go, and as ever, commenting, this is a demo of concatenation. Kill that, and we can do it. So let's declare an integer, a little variable box. I want to call it my integer. You can call it whatever you want, and let's put it to a value of 6. Now, if I print that out and go system.out.println, the variable, as you expect, we're just going to get a 6. The thing is, I want to write my variable is 6. So we can add some text before my integer, and this is called concatenation. So I'm going to make a little space here, put some speech marks and put my variable is, little colon, and then the concatenation part is the plus. So what the plus is going to do is it's going to add that bit to that bit and show us the result on screen there in the console. So if I run that, you'll notice that we've got my variable is, that's and colon, that's the text we wrote, and then the 6. So there's no gap there. So there's a couple of things we can do to get that gap. The simplest way is just simply to put a little space there, and then you've got that. But you could technically also, and we saw this in one of the last videos, is put a single space in another line. So you've got my variable is, : colon, no gap, plus a gap, plus the integer. And that should give us the same result there. So we could keep doing this. Let's just go back to that and create another integer. Another integer. You know what? Let's go for something else. Let's go for a double. My double. Call it 9.6. And what I want to do is print out my integer is that, and then directly after it is put and my double is, and then with the plus we can put my double. So it's probably going to be shorter gap here. Let's have a look. So my integer is 6, no gap, and my double is 9.6. So again, we can just put a gap there to resolve that problem. There you go. So concatenation, quite simple. Once you get the hang of it, give it a go, see how you get on. Good afternoon, Java developers. Okay, so this video is about logical operators. So a logical operator is something we've encountered already in Introduction to Computing when we looked at logic gates. So you'll remember that in our logic gate work, we looked at an AND gate, an OR gate, and a NOT gate, besides a few more. So we can model the operation of these gates within Java quite easily. So let's start with the AND gate. I'm going to bring up the truth table for an AND gate here. So just a quick reminder then. Now, what's important here is that 0 represents false and 1 represents true. So you'll notice that with an AND gate, input A and input B have to be set to true to give an output of true. Any other condition of A and B having a 0, so if A and B is both 0, if A is a 0 and B is a 1, A is 1 and B is a 0, then you're going to have false on the output. So we can model that situation within Eclipse. Let's try it. So I'm going to set up a Boolean variable. So this is our box that holds a Boolean value. I'm going to call it condition, and I'm going to set it to, let's go for true and true. So here, this is essentially our output. The condition is saving our output here, and that first value is our A, and that second value is our B. So if you compare that to the truth table, that first value there is A, and that second value there is B, and our output will be saved in the variable condition. Okay, so let's try and print out the result. So system.out.println and then condition. What do you think it's going to be? If we have A and B set to true, our output should be true. Let's check it out. And there it is. So for the other conditions, any other combination should give us false. So we'll try A and B as 0 and see what happens. Let's make that false. Let's make that false as well. And there you are, we've got false on the output. Setting any of these to true is going to give us false on the output as well, following the logic of the AND gate. Great. So that's our AND gate then. So both these values have to be true to produce an output of true. Let's move on to the OR gate. So the OR gate, which is here, gives us an output of 1 as long as either A or B have an input of 1. So we could have A and B as 1, so A and B is true, A is true and B is false will still give us an output of true. So again, we can model that situation within Java. Now the symbol for an OR are these two lines here. So you'll find those upward lines, well, on a Mac at least, above the Shift key on the right-hand side of the keyboard. So I'm going to set both of these to false. And according to our truth table, we should get false on the output. There it is. Now, according to our truth table, any other combination, as long as either A or B are set to true, should give us a true on the output. So let's try those. Let's go true there. And we have true on the output. Let's swap them over. Again, true. And finally, both true, true on the output. And there we go. So the last gate, or logical operation that we want to look at, is the NOT. Now this is an inverter. So anything that you supply in the input is flipped over on the output. So if we input false, then we're going to have an output of true. If we have an input of true, then we're going to have an output of false. So again, we can model that within the Java language. So I'm going to put Boolean condition now. I'm going to put true, and we're going to try and flip that over. And the symbol to do that is an exclamation mark. So this should flip true to false. So this variable condition should now be saved as false, and it should print console. There you are. Let's try false there. And that flips to true. Okay, so we could combine logic here. We don't just have to have one logical operator in a statement like this. We could go for, we'll try an AND first. So let's put true on one side of the and false on the other. Now, as we know, if you run that, it'll resolve to false. However, if we flip the false, you're going to have true on one side and true on the other, which should give us an output of true. Here we are. So we've combined the not and the and there. So here's another. Let's wrap up and within some brackets, some parenthesis, and then we're going to flip the entire result. So you're going to work out this bit first, because we always deal with parenthesis before we deal with the not. That resolves to false, and then we're going to flip that. So false becomes true. Let's run it, and there it is. So we could put another not in there. So we need to resolve this bit first. So we have that becomes true, true and true should output true, and then we're flipping it at the end, so we should get an output of false. And there we go. So you could add OR gates in here. You could do a whole bunch of things, but it's just about understanding the kind of order of operations. So brackets first, and then what's outside the brackets next.
Bonjour. This video is about arithmetic operators.
Brian knows best. Yes, we're going to look at arithmetic operators today. So this includes operators called addition, subtraction, multiplication, division. I'm going to leave modulus for now. We're going to look at that in a separate video. We're going to look at increment today and decrement as well. So these are all operators which we use all the time within the Java language, and which will be very useful for you to know and understand quite well. So what I've done here is set up a new program called arithmetic operators. The first thing I'm going to do is create two new variables. They're both going to be integers. So the first one, we're going to declare an integer. I'm going to call it just x, and then initialize it with a value of 4. I'm then going to declare another integer, call it y, and initialize that with a value of 3. So just for completeness, let's do a system.out.println x, and do the same for y. So nothing new here we should see. We've got 4 and 3 on the output. So the idea here is, for the first one, which is additive, so addition, is to add x to y. We're going to do that within another variable. So I'm going to put int result equals x, then the additive operator, y. So our new value result should be x plus y, which is 4 plus 3, which we expect to be 7. Let's print it out. Run the code, and there you go. So that's our x, that's our y, and that's our result. So addition, pretty simple. You can keep going here. I mean, I could add 10 to that, so you can add kind of hard-coded values too. They don't have to be variables. And that should give us 17 there. So we can just daisy chain those as much as we like and add another x if you want to, which should give us 21. Okay, just excuse the video edit there. So that was addition. So now we look at some subtraction. I'm going to keep this because I don't want to keep writing it out. I'm just going to get rid of that line there. And let's go for subtraction. So what we want to do this time is you want to take away y from x. So 3 from 4, 4 minus 3. So I'm going to declare an integer again called result. And this time I'm going to go for x minus y. As you'd expect, the minus is the subtraction operator. So this should give us a result of 4 minus 3, which is 1. And there it is. Multiplication, straight on to multiplication. Same deal. Let's declare an integer called result. And this time we want to times x, which is 4, by y, which is 3. So x and star is our multiplication operator. Star y should give us 4 times 3, which is an output of 12. And there it is. Finally, for these pretty obvious ones, let's go for division. Same old story. We're going to divide, as you know, let's change this 4 to 12 so we can have a nice even result. So we want to do x, which is 12, divided by y, which is 3, which should give us a result of 4. So let's go for x there. Now the division operator is a /, like that, and then y. So 12 divided by 3, so it gives us 4 on the output. And there they are. So lastly, let's look at the increment and decrement arithmetic operators. So I'm just going to get rid of all this to give us a bit more room, and I'm going to declare a new integer and call that count, initializing it with a value of 1. So what we're doing here is using these two operators. Now the plus plus, when applied to a variable, is going to increase its value by 1. And the decrement, if applied to an integer variable, is going to decrease its value by 1. So let's try that. So if we start with count equals 1, if I put count plus plus, which is our increment operator, semicolon at the end, and then print out the result. So we're just printing out the variable count here. We should find that 1 becomes 2, so we're going to have 2 on the output. So just to run that, and there's 2. Now I could do that once more. So 1 becomes 2 using the increment operator there, and once more becomes 3. So you can do that as many times as you want, and you can increase that variable by 1 each time. So if I change count to something like 10, and then go for count minus minus, this is going to remove 1 from the value. So applying that, we should get 9 on our output. And there's our 9. Again, we can add 1 more after that, so minus minus, which should give us 8. So we start with an initial value of 10. Using the decrement operator, go down by 1 to make it 9. Using a second decrement operator, we go down to 8. Just for completeness, let's try an and after that. So plus plus. So that's the increment operator again. So we start with 10, minus 1 to take us to 9, minus 1 to take us to 8, plus 1 should take us to 9 again. And there's the result just there. So we don't have to decrease and increase by 1 each time. We can do by whatever value we want, whatever whole value we want. So if I want to increase by 2, I don't just put 4 pluses as I've seen people do in the past. You put plus equals and then whichever number that you want to increment by. So plus equals 2 will increase the value of count, which is initially 10, by 2. So we should see 12 at the output when I run this code, and there it is. So plus equals 10 should add 10 to that value there. So we start at 10, we add 2, we add 10, and then print the result. So this should give us 22. And there it is. Very similarly, let's go for minus equals. So count minus equals 2 is going to take the initial value of 10 and minus 2 from it. So printing that should give us a value of 8 in the console. And there it is. Let's minus equals 5. So starting with 10, we take away 2, we take away 5, which should give us a value of 3. Once more for completeness, once we've done that, we're going to plus equals 20. So start with 10, minus 2, minus 5, and add 20, which should be 23. There we go. So that's addition, subtraction, multiplication, division, increment, and decrement. They're all arithmetic operators. See you soon. Hello. So in the last video we looked at arithmetic operators. So that included addition, subtraction, multiplication, division, increment and decrement. But we deliberately left out modulus. This is because modulus is slightly more difficult to understand and some people find it hard getting to grips with it straight away. So a separate video is probably a good idea. So to understand the operation of modulus, you need to know a little bit about division. So here, when you divide two numbers, well, one number into another, you end up with something called a quotient, which is essentially how many times, and a remainder, which is what's left after the calculation. So in this example here, when we're dividing 12 by 2, you'll get a quotient of 6 because 2 goes into 12 6 times, and there's a remainder of 0. Now if you do something like 8 divided by 3, you'll notice that we have a quotient of 2 because 3 goes into 8 twice. It can't go into 8 3 times because that you require 9 at the top there. But you get a remainder of 2 on that calculation. So 8 divided by 3 gives you 2 with a remainder of 2. Now the modulus is the remainder. So just to be clear, we could do 15 and 4 gives us a quotient of 3. So 4 goes into 15 3 times and it gives us a remainder of 3. So the modulus is the thing we're interested in, is the remainder. So we can have a go at that within Eclipse. So if I start a new integer, and let's declare that and call it result, and then let's put a calculation here. So the last one we did was 15 and 4. So if I do 15 and then modulus 4, the output here, the result, is going to be the remainder of 15 divided by 4. As we can see here, the remainder is 3. So result should be 3. So if I print this out, system.out.print, typing is terrible today, print ln, and then put result, you'll notice that there's a 3 on the output there. So we could do another one of those. So let's do 10 and 2. Now 2 goes into 10 5 times and it produces no remainder. So that means the this calculation will resolve to 0, which means we'll have 0 on our console there. And there you go. So what's the point of modulus? Well, one example is it's very good at finding out if a number is even or odd. Now the way we can do this is just to try and find the remainder when we use 2 as the right hand side of the equation. So if I put 2 in here, we know 2 to be an even number. Run it and we're going to get now a remainder of 0. If you put 3 in, which we know to be an odd number, we get a remainder of 1. We keep going, 4, which is even, output of 1, so 0, and 5, which gives us 1. And as you can see, we can just keep doing this. So a large even number, 862, will give us a remainder of 0, but 999, because it's odd, will give us a remainder of 1. So we can use that within larger programs to try and find out if the number that we're testing is an odd or even number. And watch out some later videos where we're going to do some examples that require the modulus to find out those odd or even numbers. So just a quick one, but a pretty important one. Thanks very much. Hi folks, so this video marks the end of a very short little segment in our series that deals with operators. So we've looked at logical operators and arithmetic operators, and we're going to finish off by looking at relational operators. Now relational operators deals with these 6 operators here. So we have the equal to, which is an equals equals, that's the sign for that. We have not equal to, which is an exclamation mark, which you should remember from the not, logical operator, and an equal sign after that. Greater than, which is a symbol we see quite a lot, which looks like that, and a less than, which is a chevron, which is small on the left and large on the right. Greater than or equal to, which is a greater than sign and an equal to after it, quite logical. And our less than or equal to, which is a less than sign with an equal to just after it. So these test 2 values and will resolve at either a false or a true. So the best thing to do here is just to jump straight into it and we can understand them a little bit better. So we'll begin with the equal to. So we're going to build up a little test program here called relational operators. So the first thing we want to do is look at equal to. So if I put 6 equal 6 there, this is we'll call this a statement. So this is a statement. So we're saying that 6 is the same as 6. So this will either resolve as a true statement or a false statement. Now we know this one is true. If I put a 9 at the end, then this statement will of course resolve to false. So we need to save the output, the result of that, into a variable. Now what variable do we know that is either true or false? Well, that's a Boolean. So I'm going to set up a Boolean. So Boolean variable, let's call it result, equals, and then we have our statement on the right hand side there. Okay. So if we go back to 6 and 6, we know that to be true. That's going to resolve as true. So let's try and print out the variable Boolean. Okay, so put result in there. So we know that is true. And let's see what it's going to look like on the console. So that's true there. Wow. Angle grinder. Okay. Right, so 6 equal 9. That's going to be a false statement. So false is going to be what's stored in our variable result there. So if I just run that, we get false. So that is our equal to operator. Now it's worth noting a bit of terminology here. The 6 and the 9 here are what are called our operands, which essentially means that we can manipulate them with an operator. So we have the operand 6 there, the operand 9, and the operator equal to in the center. So let's look at not equal to. Now not equal to is, you might have guessed, is the opposite of equal to. So we're trying to figure out if this statement here is true or false. So 6 is not equal to 9. Well, that's true. That's a true statement. So we should get true at the output there. There you go. Now if I change this to 6, 6 is not equal to 6 is a false statement. So we should get false on the console. So now we've got equal to and not equal to down. So let's look at the next one, which is less than. So the less than is going to compare the operand on the left to the operand on the right. So if I put a 3 on the left hand side and say a 9 on the right hand side, and then figure out if this is now a true or false statement, we can see that it is true. It's a true statement. So running that will give us true on our console. Just a bit of a sanity check, flip them around. So now we're asking if 9 is less than 3, which of course is false. So that gives us a false on the console there. Moving on to greater than. If you put a 6 on the right hand side, so the operand on the right is a 6 and the operand on the left is a 10. We want to know if 10 is greater than 6. That's a true statement, so we're going to get true. That is so noisy. Let's go for 2 is greater than 6. That is a false statement. So of course we get false on the console. Now there are 2 others, and essentially they are greater than or less than, they're extended using an equals. So here we're asking if 3 is greater than or equal to 3. Now that of course is true. Now if we remove the equals, that would be false. 3 is not greater than 3, but however it is greater or equal to 3. So we will get true on the output. We can flip that around. Let's put some new numbers in. Let's go for 7 and 4. So we're asking here, is 7 smaller than, less than, or equal to 4? Well, no, it's not. But of course, if we put 7 in there, then is 7 less than or equal to 7? Well, that's a true statement. So we get true. Now we don't have to have, and we generally don't have when we're producing working programs, is hard-coded, hard-set numbers, hard-set values as operands here. Usually they tend to be variables. So let's just make sure we understand that that works. So if I just set up 2, if I just declare 2 variables, let's call one A, set that to a value, initialize the value of 4, and we'll declare a variable B and initialize that with a value of 10. So the question is then, is A equal to B? Well, no, it's not, because A is 4 and B is 10. A is not the same as 10, so we should get false here. If I was to put a less than, so is A less than B, so is 4 less than 10? Well, yes it is. So we get true on the output there. And you can extend that and extend that. You can use several operators in these statements. It doesn't just have to be one. You use as many as you want. But the point is here that it'll always resolve to either true or false. So we use these a lot in if statements, which is going to be the topic of our next video. So make sure that you check that out. Thanks very much. See you then.